Last thing we're going to do with our ellipses is use the key features in order to write the equation. In order to write the equation, we need the pieces of information h and k from the center. We also need the value for a, and we need the value for b. And so like with our previous examples, drawing a sketch is going to help a lot in helping us orient ourselves within our ellipse. So we're given some information starting with the center at -1, 1. So we can draw a little sketch with our center located here at -1, 1. Well, that easily gives us our values of h and k, so that part's done. We're also given the location of one of our vertices as well as one of our foci. So our vertex is located at -1, 5, which is somewhere up here. And then we're given a focus just below that at -1, 4. Now, since we're given the vertex and the focus and they're in line, we know that we have a vertical axis ellipse and that we've been given the length of the major axis. And so our ellipse will look something like this, with our center located where it is. So now we need to find the values of a, b, and c. Let's try and start with a. A is the measure from the vertex to the center. And since we're given both of those, the major vertex as well as the center, we just need to find the distance between those 2 points. Well, we can count and see that they have a distance of 4. We can also use our distance formula to verify it if we're having trouble counting. Recall that the distance formula is the difference in the x's squared plus the difference in the y squared, and then we'll add those and take their square roots. So if one of our points is at -1, 5 for the x and y value, and then we go ahead and subtract the other point, it's -1 and -1 for the y values, then we end up with 0 squared plus, it's a positive 5, plus 4 squared. So we get the square root of 16, which is 4, which verifies that distance. So our a value is 4. Now our b value is the distance from center to minor vertex. And we don't have the minor vertices at all, but what we can do is use the c value in our Pythagorean relation. So our c value is 3. It's the distance between focus and center. And so since c equals 3, we can then use our relation b squared plus c squared equals a squared. So we're solving for b. We have c squared as 9 and a squared as 16. So b squared equals 7 and b equals the square root of 7. So now we have everything that we need in order to write our equation. Now we have to consider the direction of the major axis. Since it's a vertical major axis, we know that a is going to be underneath the y term. So we have our equation x minus h squared over b squared plus y minus k squared over a squared equals 1. And we substitute in our values for h, for k, for a, and b as well. So we'll have x plus 1 squared over 7, y minus 1 squared over 16 equals 1. Let's take a look at our next one and see what information is given. We're given the vertices and we're given the foci. Now we don't know whether or not the vertices are major or minor, so let's draw a sketch to see if we can figure that out. We have vertices located at 4, 0 and -2, 0, and then our foci are located at 3, 0 and -1, 0. So that does indicate that we have a horizontal axis. So we'll be using the formula where a squared is underneath our x term. So let's find our values of a, b, and c. So a, well, first we need to find our center, which is going to be right in the middle between the vertices and the foci. So we can try and count. Again, we could also use our midpoint formula. Sum of the x's divided by 2 and the sum of the y's divided by 2 will give us our midpoint. So let's take the vertices, for example. Our x's are 4 plus negative 2, and the y's are 0 plus 0. So with negative 2 over 2, we get negative 1, comma, 0. So we know where our center is located. Positive 1, comma, 0. Center is located at 1, 0. So now that we have h and k, we can go ahead and find the distances to the vertices and the foci to get a and c. So if our center is at 1, 0, and one of our vertices is at 4, 0, then that means that our a value is 3. If our center is at 1, 0, and our foci is at 3, 0, that means that c has to equal 2. So now our Pythagorean relation in order to find b. C squared is 4, a squared is 9, so b squared equals 5, and b is the square root of 5. We'll go back to our equation, and we'll substitute the values in. Our center was located at 1, 0, so x minus 1 squared. And since it's a horizontal axis, a is going to be underneath the x squared term, so a squared is 9. Plus y minus 0, we don't need to include that, so it's y squared, over our b squared is 5, equals 1. For our last one, we're given h and k again, and we're also given 2 vertices. So let's sketch this out and take a look at what we have. So at 3, negative 2, we have our center. Then for one of our vertices, it's at 3, negative 7. So 3 and then lower than that at negative 7. But our other vertice is at negative 7, negative 2, which is way over here to the left. So they haven't given us the vertices on the same axis. They've given us a major vertice and a minor vertice. So they've given us the values of a and b. We just need to figure what each of them is. So we can find the distance between these points. So using our distance formula, we can take the x values and subtract them. 3 minus negative 7 squared, plus negative 2 minus negative 2 squared. Our distance ends up being 10. So the length of this semi-axis is 10. And then to find the distance between the other 2 points, the difference between the x values squared and the y values squared, and so the other distance is 5. And so since this shorter distance is 5, that's the value of b, and the larger distance is 10, that's our value for a, and that means that's also our major axis. So since our major axis is horizontal, we'll have the a value under the x term. So we fill in our center. Center is located at 3 and negative 2. A squared is 100. B squared is 25. And set it equal to 1.